All right, let's go ahead and summarize what we've learned in this first part of the unit. So when you're exploring that vocab on Quizlet, we do just need to know the name of these particular polygons based on the number of sides. So I would recommend either using those Quizlet flashcards or making your own to kind of study those. So let's move on to this next part. We explored part 2 in that applet that was on GeoGebra. So we said that the sum of the interior angles in any n-sided polygon is represented by 180 times n minus 2. And we said the n minus 2 part, that n minus 2, that represents the number of triangles that are inside the polygon. And we said that these triangles are formed by connecting one vertex to all the others. So the 180 degrees that we know is in each triangle, however many triangles there are, that's gonna give us the sum of the interior angles of that polygon. So we did not really explore the second concept. So the measure of one interior angle of a regular n-sided polygon. So when we talk about a regular polygon, what we mean by that is a polygon that has congruent sides and angles. So I'm going to say that all sides are congruent and all angles are congruent. And the regular polygon we've worked with a lot this year is the equilateral triangle. So an equilateral triangle, we know it's equiangular, meaning all the sides are, all the angles are congruent, and equilateral. We could use those words too to describe other polygons, equilateral and equiangular. All right, so that formula, or that equation, is going to be 180 times n minus 2 divided by n. So based on the formula to the left, we know 180 times n minus 2 represents the sum of interior angles. So like adding up all the angles inside the shape, that's the sum. And then divided by the number of total angles. So just to look at that real fast with a shape that we're really familiar with, the triangle. If I wanted to know what's the measure of one interior angle in an equilateral triangle, we should already know that. It would be 180 times 3, because it's 3-sided, and 3 angles, so 3 minus 2 over 3, because n would be 3 for a triangle. And that would be 180 times 1, which is 180, divided by 3, which is 60 degrees. And that's something we already know about an equilateral triangle. All right, so we're just going to work a couple of examples with that information. So in example 1, what is the sum of the interior angle measures of a heptagon? Well, first we need to know that a heptagon has 7 sides. So that prefix hept, 7 sides. So we want to use the formula 180 times n minus 2. If it has 7 sides, n is 7. So 180 times 7 minus 2. So order of operations, we're going to subtract. That's 180 times 5. And 180 times 5 is 900. So the answer is 900 degrees. All right, for the second example, what's the measure of one interior angle of a regular 14gon? So in other words, we know a 14gon is a 14-sided polygon, and if it's regular, all of its sides and angles are congruent. So if I just want to know the angle measure of any one of them, they're all going to be the same. We're going to use the same formula as what's right above. So 180 times n minus 2, so times 14 minus 2, and then all of that over n, so divided by 14. So So that's really going to be 180 times 12 divided by 14. I'm going to use a calculator. I'm just doing it off screen. So 180 times 12 is 2,160. So again, that top numerator, that's the sum of the interior angles inside a 14-sided polygon. And then when I do 2,160 divided by 14, I get a decimal, and that's okay. We get about, I'm going to actually do the approximately equal to, because it's not a nice decimal, 154 point, I'm going to say 286 degrees. Oftentimes we'll get a nice whole number, but sometimes we don't. So that particular one does not have a whole number answer. All right, and then the last example for this section is to find the measure of x in the figure below. So first of all, we can tell that this is not a regular polygon because all of the angles are not the same. So I need to know what type of polygon it is. So I can count the sides or the angles. So there's 1, 2, 3, 4, 5, 6 sides and angles. So if n equals 6, we know that that is a hexagon. All right, so we want to use the formula to find the sum of the interior angles of the hexagon. So since n is 6, I really need to find what those angles should add up to. So I'm going to find the sum of the interior angles. So that's going to be 180 times n minus 2. So it's 6 minus 2, which is the same as 180 times 4. And 180 times 4 is 720. Oops. All right, so all of those angles should add up to 720. Now we just got to add them up to be able to find x. So that means that I'm going to start with 97. So 97 degrees plus 108 degrees plus 134 degrees plus 165 plus 72 plus 3x. All of that should equal, I'm going to write it down here, I'm running out of room, 720. So I'm just going to carefully add those up off screen. So 97 plus 108 plus 134 plus 165 plus 72. I'm not going to add, I can't add 3x to that, but when I combine those constant terms, I get 576, and that plus 3x, oops, should add up to 720. So now we could just solve this algebraically. We could subtract 576 from both sides of the equation. So 3x equals 144, and then divide by 3. So x equals 48. So we know that angle that's right here, that's not 48 degrees. That angle is 144 degrees. But when we're asked to solve for x, it's just that x that equals 48.